So now let's talk about the integer types. Again, for purposes of orientation, the integer types are a member of the fundamental types in C++. And indeed, within its fundamental types, C++ provides several options for working with integer values. First, we have what we might consider the plain integer type. So just int x. This is probably not a surprise considering we've been using this int as the return type for main all along, and likely you've encountered ints many, many times in your previous programming experience. By default in C++, if we say int, we're getting a signed int. We could be more explicit about that if we wish, simply by saying signed int x. And by contrast, if we wanted to make sure we have an unsigned int, we just have to say unsigned int. Now, as an abbreviation for these types, to save ourselves a little bit of typing, we're actually allowed to dispense with the word int if we're saying signed or unsigned, so we could just say signed x, or we could just say unsigned x. And in this case, we'd be getting a signed int x or an unsigned int x accordingly. Now the width, and therefore the range of our integer types, depends on the compiler. Usually they're 4 bytes wide, so they would range from -2 to the 31st, all the way up to 2 to the 31st minus 1. Again, corresponding to that notion that we're dealing by default with a signed int here. We just said int x. And if it is indeed 4 bytes wide, which means 32 bits, that's going to give us a range all the way from, in terms of the lowest negative value that we can represent as -2 to the 31st, and it would go all the way up into the positive range as far as 2 to the 31st minus 1, representing just that maximum range that we can have of a 4 byte wide signed value. So for example, we could store all the way up to $2,147,483,647 in our regular int here. One nice feature that C++ offers is, see, for a long number like this, it might be a little bit difficult to read exactly which value we're talking about. So it allows you to put single quotation marks to delineate what we would normally think of as the comma separators, just to make it a little bit more readable. So if that's our basic int data type, we can also declare what's called a short int. Now in regular usage, we'd probably leave off the int and just call it a short. But either way is syntactically correct. You could say short x or short int x. They're both the same thing. Again, just to save some typing, people tend to say short rather than short int. Now, as with the regular int, the quote-unquote regular int, this is by default a signed value, but we can be explicit about this choice, or we can make it an unsigned short. So we could say signed short x. We could say unsigned short x, depending on our desires there. When would we use a short as opposed to just an int? Well, we could use it if what we're after is a narrower version of an int, maybe in terms of storage and therefore its range. The width, again, depends on the implementation, but it's often 2 bytes wide. So in that case, it would range from -2 to the 15th up to 2 to the 15th minus 1, right? Now moving in the other direction in terms of width and range, getting wider rather than shorter, we have a long int. And as with a short, we typically just call this a long. Again, this is by default a signed integer value. We can make that explicit as before or change it to unsigned simply by using the keywords signed and unsigned. And again, if we wish, we could go ahead and say int as well. So we could have unsigned long int, or we could just say unsigned long, right? You're getting the idea here in terms of these variations, I think. Now I said we're moving in the other direction in terms of width. In the case of a long, this is actually theoretically a longer version of an int, as the name would imply, but in reality it's often just stored in 4 bytes, just like an int, so that makes it the same size as an int. Now if we want to supply a value, a literal long value, into this variable, we need to append an L to the value itself. If we don't do that, what's going to happen is this 33, for example, here in this case, is just going to be treated as an int. You can see that when I hover the cursor over it in Visual Studio. See if I can zoom in on that a little bit. See, it's just being interpreted as an int initially, and then it's going to be stored and converted over into a long, which is not really what we want. We wanted it to be a long from the beginning. So we need to append an L to that literal value. And continuing up the ladder in terms of width and therefore range, well, you guessed it, we could have a long int. And as before, typically instead of saying long int, we'd probably just say long. Now this type is often stored in 8 bytes, and in that case it would range from, what, -2 to the 63rd all the way up to 2 to the 63rd minus 1. As before with longs, if we want to supply an actual literal value to be stored over into this variable, we need to make accommodations for that. Otherwise it's going to be interpreted by default as just an int. And so we need to append an LL to that literal value. Therefore, this 33 is going to be interpreted immediately as a long and stored over into the corresponding variable y. Okay, so are you overwhelmed yet? Yes, it does seem like a lot, right? All these choices can seem a little bit perplexing at first. They really just come down to choosing what size of integer you want and then deciding whether you want it to be signed or unsigned. And as you saw, there are a lot of variations in syntax that are possible, but with a little practice, they'll become intuitive enough. And frankly, most often, what you're going to see and use is just a good old int. For the sake of completeness, though, I wanted to introduce you to these data types in case you see them in your textbook, you see them online, and eventually you may get to a point where you actually want to optimize your program for storage space or range and so forth, and you'll want to know that these are available to you.